So coordinate axis. See, x-axis, y-axis. So origin 0 comma 0, x dash, x, y, y dash. These are coordinate axis. This can be written as, let us denote with small x dash, small y, and small y dash. Right? Here, without changing the direction means, so this side, otherwise that's a left or right. We are not changing the direction, but we are shifting horizon to some other point. Let us suppose that take any point on a plane x comma y, and the horizon is here, which will be shifted to some other point without changing the direction of the axis. Suppose the horizon is here, now at here, then which becomes, this is x-axis, capital X, x dash, and this is y-axis. This is capital Y and O dash and capital. So now the representation of new axis and old axis. This can be represented as x dash ox, x-axis representation, comma, that is y o y dash, and then new axis representation, x dash o dash x and y o y dash, right? Now the coordinates of new horizon are h comma k. Let us suppose that. So what is meant by transformation? Without changing the direction of the axis, shifted to some other point, then that transformation is called transformation of axis. Transformation of axis. Transformation of axis. If the origin is shifted to another point, if the origin is shifted to another point, without changing direction of axis, then the transformation is called, transformation of axis. Transformation of axis. Suppose let O dash h comma k, let O dash is equal to h comma k. Let us write a statement here. If the coordinates of, if the theorem, this is if the coordinates of a point x comma y, the coordinates of a point x comma y are transformed to capital X comma y, and the axes are translated to the point when the axes are translated to the point h comma k. The axes are translated to the point h comma k. Then x equal to x plus h, y equal to y plus k. If the coordinates of a point x comma y are transformed to capital X comma capital Y, then we can expect this much of change when you transfer the axis from one point to another point without changing the direction. So before that, the point is small x comma y. When the axes are shifted to some other point, then the point becomes capital X comma capital Y. When the axes are transformed to the point h comma k, the origin, before that the coordinates of origin are 0 comma 0, now the coordinates of origin are h comma k. Then small x equal to capital X plus h and small y equal to capital Y plus k. Let us see the proof for this theorem. Proof. Suppose let O dash equal to h comma k. O dash equal to h comma k, and mu coordinates of the point, are x comma y. Here x dash o dash x is parallel to x dash o x. X dash o dash x is parallel to x dash o x, and projection of y axis, projection of y axis, I mean to say y dash y, y o dash y dash, projection of y o dash y dash on x dash o x. X dash o x is, let us suppose that n. Let the projection of y o dash y dash on x dash o x is n. So projection means nothing but a perpendicular is n, and projection of p on x dash o dash x. Let us draw a projection from P to two parallel axes. What are the two parallel axes here? X dash o dash x and x dash o x are the parallel axes. Let us suppose that this is M and this is L. Meaning of that, the projection of P on x dash o dash x is M, and on x dash o x is L. Projection of projection of P on x dash o x dash o x and x dash o x dash o dash x and x dash o x are M and M comma L are projection of P on x dash o dash x and x dash o x are M comma L respectively. Right? See, when the origin is shifted to O dash, then the coordinates are changed. Now the coordinates of P are capital X comma capital Y. Then the distance from origin to P is capital X. That means this is capital X and this is capital Y. Totally this is, I mean to say PL is small y and then OL is small x. Here we have to observe one thing, that is NLM O dash is a rectangle. When the rectangle form, then opposite sides are equal. Meaning of that is NL equal to O dash M, at the same time O dash M is equal to MN, right? So here OL equal to, now OL equal to, OL can be written as NL plus OL. NL equal to, I said that NLM O dash is a rectangle, so NL is equal to O dash M, so O dash M is equal to X as well as NL also X, which is equal to OL equal to X small x, NL is equal to capital X plus ON. Now see here, ON equal to H and O dash N equal to K. Then ON is equal to H, right? Comma PL equal to PM plus ML. PM plus ML. What is PM here? What is PL before that? PL is equal to Y. And then PM equal to, what is PM here? PM equal to capital Y plus ML. What is ML here? ML equal to, we don't have ML value, but NLM, O dash is a rectangle, so O dash n equal to ML. That's why ML equal to K. Hence proved. See, the origin is shifted without changing the direction of the axis. Then the coordinates are small x is equal to capital X plus H and small y is equal to capital Y plus K. Right? This is called transformation of axis. Next. If the axes are translated to the point h comma k, then the equation f of x comma y equal to 0 of a curve is transformed into x plus equation of a curve. Note, equation of a curve is f of x comma y equal to 0. That means x square ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. F of x comma y equal to 0 is a curve, means we have to remember this is the form of that curve. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Suppose this is first point you note. Second point, the origin is shifted to h comma k, and then the equation of the curve transformed as the axes are translated to, if the axes are translated to the point h comma k, then the equation f of x comma y equal to 0 transform f of x comma y equal to 0 of a curve transformed as f of, you have to remember that small x is equal to capital X plus H and small y is equal to capital Y plus K. So instead of small x and small y, present that values. So capital X plus H comma capital Y plus K equal to 0. So before that is f of x comma y equal to 0. Now which becomes as capital X plus H comma capital Y plus K equal to 0. This is the form of new curve. Suppose f of x comma y equal to 0 is transformed to the equation of the curve and the axes are translated to the point h comma k, then the original equation of the curve. Already here the axes are translated to the some other point, then the curve has been transformed as capital X plus H comma capital Y plus K equal to 0. Then what is the original form? First suppose that if f of capital X comma y equal to 0 has been transformed by the axes are translated to point h comma k. if f of x comma y equal to 0, the is the transformed equation of the curve is the transformed equation of the curve when the axes are translated to when the axes are translated to h comma k, then original equation of the curve, then original equation of the curve f of original equation of the curve is x minus h comma y minus k equal to 0. X minus h comma y minus k equal to 0. See, capital X comma capital Y has given here. He wants equation in the form of small x and small y. So capital X equal to small x is equal to capital X plus h comma small y is equal to capital Y plus k. Then I want here capital Y and capital X. So capital X is equal to small x minus h comma capital Y is equal to small y minus k. That's right. The equation has transformed into x minus h comma y minus k equal to 0. The next thing, the point which the origin has shifted to the eliminate x comma y terms. See, equation of a curve means you have to remember always ax square plus 2hx square plus by square plus 2gx plus 2fy plus c equal to 0. The equation has been shifted to, the origin is shifted to some other point and eliminate the terms x and y. Then h of minus bg by ab minus h square, gh minus ab, gh minus af by ab minus h square. For that proof we'll learn in next class. So write the formula directly here. The proof we'll learn in next class. Try to understand this second note and third note. If the axes are translated to the point h comma k, then the equation of f of x comma y equal to 0 of the curve transformed as capital X plus h and capital Y plus k. Why? Because small x is equal to capital X plus h and small y is equal to capital Y plus k. Here, don't get confused. The second one is f of x comma y equal to 0. Try to find the difference between second note and third note. Here I use small alphabet, but here I am using capital alphabets. So the transformed equation has given which are translated to the point h comma k. Then the original form of the equation is f of x comma h minus y minus k equal to 0. Next, third one. Now fourth one is the point which the origin shifted. The point which the origin has to be shifted, origin has to be shifted to eliminate the xy terms, to eliminate x comma y terms, in what is the equation of curve here? ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is hf minus bc by ab minus h square gh minus af by ab minus h square. Here ab minus h square not equal to 0. ab minus h square not equal to 0 since first suppose which is 0 which is not definite. The point which the horizon has to be shifted to eliminate x y comma y terms in ax square plus 2hx square plus by square plus 2gx plus 2fy plus c equal to 0 is hf minus bg by ab minus h square and gh minus af by ab minus h square. Right? So remember, the point which the horizon has to be shifted to eliminate the x comma y terms in. Suppose hy term not presented, then what happens? Let us see now. Note number 5. Number 5. The point which the horizon, the point which the horizon has to be shifted to eliminate x comma y terms in x comma y terms in ax square plus by square plus 2gx plus 2fy plus c equal to 0 is, see, suppose h is equal to 0, the term h is not presented here, so h becomes 0, so this becomes 0, then minus bc, let us write here minus bc